I want to welcome everyone to the Editor's Podcast for the Journal of the Academy of Nutrition and Dietetics today. I am Dr. Linda Snetzler, Editor-in-Chief of the journal. During this podcast, we will be discussing the article titled Application of Path Analysis and Structural Equation Modeling in Nutrition and Dietetics. And with me today, I'm honored to have Dr. Phil Gleason. He is a senior fellow statistician at Mathematica and has a great deal of expertise in this area. And I will be asking him a few questions related to the article that he co-wrote. And we'll begin with the first question. I wondered, Dr. Gleason, if you would define for us path analysis and structural equation modeling.
Sure, and thank you for having me. I think the simplest way to define path analysis and structural equation modeling is that these are both statistical procedures for assessing complicated relationships between large numbers of variables. In particular, each procedure aims to measure the strength of the relationship between a set of explanatory variables, which are just characteristics of interest among individuals, organizations, other entities, and a set of one or more outcomes of interest to a researcher, such as a nutrition or a health-related outcome. Now, in the real world, factors that affect these kinds of outcomes tend to be complicated, and path analysis and structural equation modeling can help researchers untangle some of the complicated relationships. To give just one example of how things can get complicated, an explanatory variable can have both a direct and an indirect effect on an outcome. For example, some characteristic like family income could directly affect an individual's dietary intake, since the range of affordable food options for a low-income family is presumably more limited than it is for a high-income family. But income can also indirectly affect dietary intake. For example, if it first affects the neighborhood that a person lives in, and then that neighborhood in turn affects their access to high quality food stores, such as if they live in a food desert. So in that case, residential neighborhood is what's known as a mediating variable. It mediates the indirect relationship between the explanatory variable income and the outcome of dietary intake. And path analysis and structural equation modeling allow researchers to estimate models that include these kinds of mediating variables.
Okay, thank you. Also wondering how these statistical procedures are different from just simple regression models.
Sure, yeah. So they're all related. They're all about estimating relationships between variables, but path analysis and structural equation modeling handle more complicated situations than simple regression. So a simple regression model could allow a researcher to estimate direct relationships between a set of explanatory variables and a single outcome. Like in the previous example, simple regression could be used to estimate the extent to which a set of individual or household characteristics explains or predicts a measure of diet quality, such as the healthy eating index. And that the regression gives you estimates of the strength of the relationships between those uh, explanatory variables and diet quality. But simple regression has a couple of limitations. First of all, in any given regression model, a researcher is only able to examine a single outcome at a time, one outcome at a time. So if a researcher's interested in looking at multiple measures of diet quality, for example, they would have to use multiple or more than one regression model in order to do so. Um, Secondly, a simple regression model examines sort of the direct relationships between explanatory variables and an outcome, and it can't accommodate the kind of indirect relationship that I was describing previously. Path analysis and structural equation modeling, similar to simple regression, but they address these limitations. They allow researchers to examine complex models that have more than one outcome, and they also can accommodate these kinds of mediating variables and allow, as I mentioned before, allow researchers to examine indirect relationships between explanatory variables and outcomes.
Okay, so what then is the difference between path analysis and structural equation modeling?
Yeah, so path analysis, as I just mentioned, allows researchers to examine models that address these two additional complexities that simple regression doesn't. Um, and structural equation model do this as well, but then they go one step further and allow for additional complications. And in particular, a structural equation model can include what are known as latent variables, which are variables that aren't directly observed or measured by the researcher. And in order to explain this, it's useful to take a step back. So the methods we've been talking about so far with simple regression and path analysis um, involve estimating relationships only between measurable or observable variables. So measurable or observable variables are variables that a researcher can directly collect data on, so like through a direct observation or a survey, or by collecting administrative data that directly measures the concept that variable is trying to measure. So this could include household characteristics like income or participation in food assistance programs, or the types of behavior that can be directly observed or reported on, like a person's dietary intake over a 24-hour period. By contrast, latent variables are very difficult or impossible to directly observe or measure. This could be, for example, a complicated concept like the level of stress that a person is experiencing. So a researcher might be interested in understanding better how stress is related to a person's diet or health outcomes. But there's no generally accepted direct method for measuring stress. And instead, the best a researcher can do really is to observe or measure various indicators of stress, things that are sort of related to stress, even if they don't directly measure exactly what the level of stress a person is experiencing is. Uh, just as an example of this, a researcher could administer a survey where they ask respondents in various ways to describe the level of stress they're experiencing, or to report on behaviors that might indicate stress. For example, they could ask respondents to say whether they're losing their temper more easily than usual. Are they having trouble sleeping? Things that one might expect are related to how much stress they're under, even if there are also other things that contribute to those indicators. So each of those indicators alone is an imperfect measure of stress, but collectively they reflect how much stress a person's experiencing. And a structural equation model allows researchers to take data on these multiple imperfect indicators of stress, um, and use all the data on those indicators in order to estimate a single value of this latent measure of stress, for each person in a sample or each person included in an analysis. Um, and then they can use that measure of stress and examine how it's related to other variables, other explanatory variables, or other outcome variables in their model. So structural equation modeling just adds this one additional layer of complexity on top of what's possible with path analysis.
And I can see how important that is in various aspects of research that go on in nutrition and dietetics. I wondered if maybe you could specifically add your thoughts on these statistical concepts and how they might apply to nutrition and dietetics.
Yeah, great question. Um, I think that path analysis, I think these methods are particularly useful for researchers in nutrition and dietetics because it's very common for research in this area to involve these kinds of complex factors that all contribute uh, both directly and indirectly to diet and health related outcomes. Um, for example, dietary behavior is often a key outcome of interest in research in nutrition and dietetics. Um, and a researcher might be interested in what factors, for example, contribute to healthy dietary practices or dietary outcomes, like, say, an increase in consumption of fruit or vegetables, or a reduction in the intake of added sugars. Uh, and uh, when you stop to think about how many factors might contribute to those kinds of outcomes, you realize it's a pretty long list. So an individual's circumstances might affect their diets, how much their family structure, socioeconomic status, um, the environment that they live in. As I mentioned before, their availability of easily accessible stores with wide ranges of healthy eating options, their participation in nutrition assistance programs, the availability of those kinds of programs, like the SNAP program or school meal programs. Physical health might affect diet. A person's social and emotional well-being could affect their diets, their mental health, or the presence of stress in their lives. So those are just a few examples, but the point is you can see how quickly the story can get complicated. Um, and path analysis and structural equation model is one way of dealing with that level of complexity. Um, and in other cases, a researcher might be more interested in how dietary behavior contributes to health outcomes. So they're looking at diet not as an outcome in itself, but as something that might explain a health outcome. And in our paper, we went through an example of a structural equation model that set out to understand the factors that contribute to high blood pressure. And in the example we presented, um, dietary measures are mediating variables. For example, an exogenous or explanatory variable like socioeconomic status might affect the extent to which an individual has a high sodium diet. And then this diet, high sodium diet in turn, affects their likelihood of having high blood pressure. But there are many other factors that might also predict a person's blood pressure. Again, the level of stress in their lives, physical activity, genetic factors. Um, and so the model, and the model sort of in our paper conceptualized some of those concepts as latent variables and some as measurable variables. So the model was very complicated, and it was describing a very complicated situation, but one that could be assessed with a structural equations model.
Yes, thank you. I know that as we look at nutrition research, often we are focusing on some of the limitations, particularly as we look at statistical analysis. And I wondered, what are important limitations of path analysis and structural equation modeling?
There's one big limitation that I think is worth really highlighting, and that's the fact that path analysis and structural equation modeling are statistical methods that are intended to estimate relationships. What they're not, are research designs that might allow a researcher to claim that a relationship that they've estimated is a causal relationship. So in the example that I just used, a structural equations model might be used to show that the level of sodium in a person's diet is positively related to their blood pressure, but structural equations modeling alone would not necessarily allow a researcher to conclude that having a diet high in sodium causes high blood pressure. To really estimate causal relationships, a researcher would need to do so using a very strong research design, like a randomized control trial. That caveat is important to keep in mind when using these statistical methods or when looking at research that others have done that use these methods.
Thank you so much, because I know often conclusions can maybe be overstated. And that's exactly what you're talking about here, making sure
Right.
that our statistical analysis will allow us to make certain conclusions. Finally, then, I wanted to ask you, how might RDNs use these statistical methods as they are reviewing research articles that might apply to their clinical practice?
Yeah, that's another great question. And um, partly because research articles showing results from these kinds of methods, from path analysis or structural equation modeling, may appear very complicated. Even so, they're complicated for a reason, and that is because showing, they're describing a complicated reality. And so they can be very useful for RDN's clinical practice because they provide so much information about different factors that might be related to key outcomes that they're interested in. For example, although a simple regression model might reveal a relationship between uh, a person's sodium intake in their diets and high blood pressure, a path analysis and structural equation model could show not only that relationship, but it could also shed light on what factors might contribute to the folks having high sodium intake in their diets in the first place. So it could be that factors like their socioeconomic status, income, access to food stores, or some other factor are really strongly related to the amount of sodium in their diets. And it's understanding those kinds of relationships that may help um, RDNs determine which factors are related to the diet outcomes that they're interested in, and how their practice might be designed to try to improve those kinds of the diet outcomes. So in reviewing research articles that include path analysis or structural equation modeling, I would suggest that RDNs not be put off by if they seem very complex. So these kinds of articles often have very complicated looking figures where there are boxes and circles that are all over the place, and they're connected by arrows that seem to also go all over the place. But it's not really as complicated as it looks when you first see it. In these models or in these diagrams, each of the arrows that you see there represents a relationship between variables in the model. And these are relationships that the model estimated. So I guess the one suggestion I would have, if you are looking at an article with one of these methods, with the results from one of these methods, and for the first time, it's really helpful to not try to understand the full set of results all at once, but rather to focus specifically on one part of the results at a time and try to understand that part first. Um, so again, path analysis and structural equation models are just ways of estimating relationships between variables. Um, and in that sense, it's very similar to simple regression, only structural equations and path analysis are examining more relationships. So by focusing on just one part of the model at a time, a reader can slowly come to understand what the full story is behind the analysis that was done, and that can be quite useful.
Yes, incredibly useful, as is the article that you wrote. Thank you so much. And again, many thanks for shedding light on important statistical concepts, specifically as they're related to the research that we do in nutrition and dietetics. And just a great deal of appreciation for what you have done in terms of shedding light on some issues that are very much statistical, but also very important as we do research in nutrition and dietetics that can often get complicated, as you have described. So many thanks.
Oh, you're welcome, Linda, and thanks for having me.